Thank you.
Thanks a lot, Fon, for the amazing introduction. So today we'll be looking at introduction to Amazon DynamoDB, what it is and how it can be used to build modern serverless applications. My name is Rosius Ndimofor. I'm a senior serverless developer at Serverless Guru. So let's take a look at the agenda for today. So firstly, we'll look at a brief history of data processing. Amazon DynamoDB is a NoSQL database. So why NoSQL? Then we'll look at SQL versus NoSQL, or maybe I should say SQL versus NoSQL. And then after that, we'll look at the benefits of Amazon DynamoDB. After that, we'll look at use cases of Amazon DynamoDB. We'll then look at the core concepts surrounding Amazon DynamoDB. And then we'll dive into a demo where we'll see how to actually create an Amazon DynamoDB table, both using the AWS console and then using code. So today we'll be seeing some code with Python, just basic stuff. It's really basic stuff. After that, we'll look at the resources, conclusions, and then do the raffle draws. So about me, like I said earlier, my name's Ndimofor Ateh Rosius. I'm a senior serverless developer at Serverless Guru. And you can meet me on any of these social media platforms, Twitter, LinkedIn, Instagram. And I also blog occasionally at Fat Rabbit Apps, where I show you how to build real-life serverless applications on AWS. So let's get started. In order to understand why NoSQL, it's good that we take a brief history down a memory lane to look at data processing. So the first database is the one between our ears, which is actually the brain. But the thing is that we cannot build an enterprise on our brain, and it's our brain is fault tolerant. It's not fault tolerant and it's not durable. So we had to look for other ways to do stuff. We started to write stuff down on ledger accounting systems. So these ledger accounting systems actually ran public and private workloads for a millennia, up to 1880, where the US Census actually, and gave permissions to a man named Herman Hollerith to actually take all this data that had been kept and process it using the ledger accounting systems. So 8 out of 10 years, eight years in a 10-year cycle, he used the ledger accounting system, but he realized that there was a problem. It wasn't efficient enough. So he went ahead in 1890 to create the machine-readable punching card system. So when he did that, that was actually a turning point in data processing technologies, because other data processing technologies started popping up. We had the paper tape, the magnetic tape, the distributed block storage, the random access file systems, and all that. So all of those technologies started popping up and people were trying it out until 1980, where the relational database management system was born. The reason why RDBM, I'll actually use the short form of it, RDBMS, that's SQL. The reason why it was actually born was because storage back then was really expensive. So they had to look for an efficient and nice way to store data, because they couldn't keep on spending millions on storage. So that's why you see one of the main features of a relational database management system is normalization. That the deduplication of data in order to store it efficiently and in a nice manner. Fast forward 40 years today, you see that the reverse is true. Storage is really cheap now, but CPU cycles are very expensive. So it now begs the question that why are we using a technology that was created 40 years ago to today's problems. We have really today most of the applications that we build today they actually require scaling. They need more scaling, and they need to be more performant. You know, so why are we using SQL to actually solve today's problems? That's what gave birth to the NoSQL uh, database. That's what gave birth to NoSQL databases. So, all right. So, in order to actually dive into looking at Amazon DynamoDB, the NoSQL, we have to see the difference between SQL and NoSQL. And we'll actually start by first looking at data storage. So storing data in, we actually store data in a SQL databases using fixed rows and columns. But in NoSQL databases, data is being stored in JSON documents in a key and also in a key value paired manner. And then with respect to scaling, as the request on your server increases, SQL databases actually scale vertically. So they actually need larger servers when the smaller servers can no more handle the level of traffic. But with NoSQL databases, data is being scaled horizontally. So they are being scaled out across commodity servers in different availability zones. And then with respect to schemas, once in SQL databases, once you've defined your schema, it's really difficult to actually update that schema. Let's take, for example, 2 to 3 months down the lane of development, the business model changes. So in order to go back in SQL databases and change that model is really, that schema is really very difficult. But with NoSQL databases, it's actually flexible. So as you're developing a business, the business model changes, you can easily change the schema, add more attributes or primary keys and stuff like that. And then with respect to development, like I mentioned earlier, SQL is actually focused on reducing data duplication using normalization. But with NoSQL, the focus is actually in scaling and performance, so rapid scaling and performance. Why is this? Okay, so now we have to look at the NoSQL database called Amazon DynamoDB. And is based on this quote, you can see it says, run your business and not your database, because at the end of the day, you want to run your business because that's what makes you the money, and not actually configuring your database. So let's look at the benefits of using DynamoDB, of using Amazon DynamoDB. So firstly, it's a fully managed NoSQL database provided by Amazon Web Services. It was created in January 18, 2012 by the Amazon.com shopping cart team. So the problem is that these guys had performance issues with using SQL. So they had to think of a better way in order to scale efficiently, rapidly, and performance-wise without any performance degradation. So all that led to the creation of DynamoDB. So DynamoDB actually lets you create a database table that can store and retrieve any amount of data and serve any level of request traffic. Like you can actually, DynamoDB does 20 million requests per second. If you can just imagine what that means. And then, like we said earlier, it's NoSQL, and it supports both document and key value store models. And it scales infinitely with no performance degradation. So when I talk about fully managed, what I actually mean is that your provision capacity read and write units are being, it's actually being provisioned for you. Read and write capacity units are being provisioned for you. Your operating system software patches are being done for you. Database backups, logging, debugging, everything is actually being handled for you. So you don't have to think about caching, some low-level stuff. All you have to do is just tell Amazon what you want, and then they go ahead to do it for you while you concentrate on building your business. And then one of my favorite points is infrastructure as code friendly. What infrastructure as code means is actually provisioning resources such as storage, uh, databases, Lambda, queues. So you provision these resources in a simple file, and then you actually upload that file to the server, and then the server installs those services for you. So the advantage of this is that you don't have to, when somebody looks at that file, he knows exactly all the resources that your application has been using, and then they can easily update the resources from that file either any time later on in the future. And also, the most of the compute services such as identity and access management, Lambda beneath the hood is actually built on DynamoDB. Also, DynamoDB has a flexible pricing model. So there's something in DynamoDB called a provisional capacity write and read units, which you can either set or you let Amazon set it based on how your application is performing. So the thing is, you can actually know the number of requests that are being sent or received from the DynamoDB. I can calculate the exact or an approximate figure, an approximate amount that your application will actually spend when running services. And again, like I mentioned earlier, it's fully managed. So just the term fully managed is worth mentioning 10 million times. So that's why I keep on talking about it so that you understand what I mean. So let's look at a couple of use cases of DynamoDB. Actually, there are a ton of them, but let's look at some of the biggest guys in the game. So we have Amazon.com shopping cart. Actually, they're the ones who created it, so it actually starts with them. Now, if you can imagine the amount of requests going through the shopping cart on a daily basis, then you know the strength of DynamoDB. Lyft also uses it to store all the rights, or the user profile and the rights on its platform. Duolingo scales to store over 31 billion items in its DynamoDB. And then actually you can build practically any web, mobile, or Internet of Things application on DynamoDB. I actually built a ton of stuff on DynamoDB on a daily basis, and it's actually super fast. I mean, the time to build and deploy application on it is really fast, and it's a really great database. So now that I've seen the core benefits, we've seen the benefits of using Amazon DynamoDB, let's look at the core concepts and the key vocabulary. There are actually 4 of them, the basics. There are actually 4 core concepts of DynamoDB. We have the table, which is synonymous to a table in SQL. We have an item, which is synonymous to a row in a SQL database. And then we have a primary key and we have attributes. So let's look at each of them individually. So this is a table. Let's draw an example from where you want to create a table to store users' profile information. So this is actually how the table structure looks like. You can see you have there's 7 items within that table. That's 7 rows, and then we have attributes, and then we have a primary key. So that's if you've worked with SQL before, you know that you just see similarities between both of them. And then why are you not clicking? Okay. And then we have item. So an item is like a row with attributes. So it's the same thing with a SQL database. So we have the item or the primary key called John, and then we have attributes called first name, last name, manager, login, alias, and skills. And then we have the primary key. So when creating your table in SQL, in SQL and NoSQL, you have to actually specify a primary key for each item that is being added to that table. Because the primary key has to be unique so that you can actually retrieve that particular item if you ever need it along your development lane. Then we'll have the attributes for each of those items. So like I said earlier, NoSQL is flexible. So even though I've defined the first name, last name, the alias, and the skills, we can go ahead to add in, let me say, the age, their sex, and stuff like that. So we can actually play around with this as our business model keeps changing. We keep on, updating this. So if all of this sounds interesting to you, then let's go ahead and see how it's being done on the Amazon console. So if you have an Amazon account and then you search for DynamoDB in the search box and open up the first screen, you should see something like this in the dashboard menu. So you can see I've highlighted the create table button, where if you want to create a table, you just click on that. When you click on that, it gets you to this screen where you have to enter the name of your table. So, well, since I'm creating a table to store users' profile information, I have my users table. And then you must create a primary key. It's required. It's actually required to create a primary key before you proceed. And then you check the use default settings because you don't know how your application will perform. So you want DynamoDB to handle most of to provision all the read capacity units or write capacity units for you. You don't want to do that manually, which is a good thing. So after that, you can create at the bottom right-hand side of the screen. You can click on the create button, which will actually create your database. So I went ahead and created a database and added an item to it. So see, I added an item with the user ID, primary key of that number, long number, and then I added my full names, occupation, age. So if you want to add more, you can just you can just click on create item. It does that for you. But let me say 9 times out of 10, you will not be doing any database. You'll not be creating tables in DynamoDB like this. You'd actually do it using code, and you specify everything in a file, in your infrastructure as code file, and then when you upload that to the server, Amazon does it for you. It fully manages it for you. You don't have to do this manual stuff. So I wrote some code, and I'll just go ahead to explain. It's actually basic. If you're not a coder, don't worry. You don't have to memorize anything. I just want to show you the little steps on how it's been done. So let's see how easy it is. So I'll go ahead to share my code editor, VS Code, and then just look at a couple of things, and that's it. Admit, okay. So I'll stop sharing this. And wait, share this. So, Mr. Fon, can you see my screen? Can you guys actually see my screen?
Yeah, I can see. I think the size of the text is okay. Yeah, go ahead.
All right. So, in this project, I have 5 Python scripts. So I have the create DB, which means create database table. We have the create user, the delete user, the get user, and the update user. Just a simple CRUD example using DynamoDB. So this is Python. If you haven't noticed, it's okay. It's Python, and you see the first line. I actually import a library called Boto3. It's actually the AWS SDK for Python, and is used to create, configure, and manage AWS resources or AWS services such as DynamoDB in this case. And then I have a create users table. Let me go ahead to mention that for this example, I actually downloaded a local copy of DynamoDB and installed it on my computer. Why did I do that? I did that because I wanted to develop this application with speed, and I did not want to do network calls for every operation I was carrying out because my internet is slow and I just want to be fast that way. So that's how I mostly develop my application. I do it locally and then I deploy it to the cloud once I'm done. And so if you see on line 13, I actually get the service resource, and then I pass in the endpoint URL for my local DynamoDB database. And then when I get that service resource on line 15, I use a method called create table to actually create my DynamoDB table. It's really easy. Well, I shouldn't say it's really easy, but it's comfortable. So with the create table method, I pass in the table name, which is users. Then I define my base schema, which is actually the primary key. My primary key for my table is a username, and username I'll give it an attribute type of string, which is S. So if it was an integer, I'd have given it the user an attribute type of N. And then if you look at for line 32 to 34, I'm actually provisioning, I'm giving default read capacity units and default write capacity units. Since I'm running my database table locally, I don't have this. This won't really this has no effect because I'm doing it on I'm using my own computer resources. But now, since I have to ship this to the cloud, then it will take effect. So I defaulted my read and write capacity units to 10 based on my resources. And then I return the table, which will actually print out the status of the table if it was created, if an issue occurred and stuff like that. So this is just a simple, this is a basic Python script to actually create a DynamoDB table. So let's go ahead and look at the script to add a user to that table. So it's still the same thing over and over. We get the resource service. On line 10, we get the table we want to save to. On line 11, we use a method called put item. No, and then the first thing is that when you want to add an item to the table, you must specify the primary key. That's the first thing. So when you specify the primary key, then go ahead now to add in your other schema attributes. So here I have an info object, which contains my occupation, my age, and stuff. I can actually go ahead and put in, let me say, sex in here. Oh, geez, really? Okay. Yeah, I can add in sex and yeah, gender and stuff like that. So sex and gender, that is something. So when I do all of that, I then return a response and then I print out the response. All of this code is hosted on GitHub, on my GitHub page, and I'll share the link in the resources. So you'll get this, and I actually urge you to get this and play around with it and see how it works. Like, try to improve on the code, try to do your own stuff. I'd like to see it, get in touch with me at any time to ask me a question or show me stuff for me to see. Then you can go ahead and get a user. So in order to get a user, like I told you, like I mentioned earlier, we give a primary key to our items, which is unique. So in order to get one item from that table, we need to use their primary key, which we actually do on line 13. So use the method called get item, and then we pass in the primary key username, which we send in here on line 21. So it gets the primary key, gets into the table, searches for that primary key, and then returns the result. If there's an error, it prints out the error. So it actually returns the item here, and we actually print out that item on line 24. So it returns the item on line 17, and then we print out the item on line 24. So the other Python scripts are basically the same thing, just repeated methods, but same idea. And all of this code is posted on GitHub. I urge you guys to try it out, improve on it, and then show me what you can do with it. Like, explore DynamoDB. Remember, this is bare bones basics of DynamoDB. There's still a ton to look at, and we'll actually be breaking it down with every meetup session. So That's all for the code presentation. So let's go back to the slides. Okay. All right, so let's look at resources. I mean, the first one is the official DynamoDB website from Amazon.com, which has everything. So you can look at the APIs, you can look at sample little practical examples and stuff like that. And then here's a link to download a local DynamoDB database and install it. It has some sweet instructions to install it on your machine and try it out. But if you don't want to go through this stress, you can just use the one on Amazon or the one online, which is also perfect. It's the same thing, just that it's hosted. But I like using the local version because even without the internet, I'm still going. So on my blog, the name of my blog is fatrabbitapps.com. So I have actually a blog series called DynamoDB Demystified, where I break down DynamoDB from the basics to intermediate, not advanced, intermediate, and I actually do that with practical examples, like real life examples. So I urge you to try to check it out, and if there's anything, I'm always ready to pair program with you or to help you with your issues. And I think that is it. Thank everybody for listening to this sweet conversation about DynamoDB. So over to you, Mr. Fon Nkwenti.
All right. Thanks, Rosius. I mean, there are a couple of interesting things that you said, which are quite interesting. I think we have a couple of questions in the chat from Mandela. But anyway, just one or two remarks from my end. I am not a programmer, I'm not a DB person, a network engineer, but one of the things that you said, which I find really interesting, is the fact that you can programmatically, build your DynamoDB table, right? And the advantage of doing this is that your database is practically code. And this means that, it can be easily reproduced, it can be automated. Best practices, for example, you can create templates, you can version control it, you can easily roll back, etc. But you mentioned that you are running the DynamoDB locally on your machine, on your computer, right? But I've always known that in order to use DynamoDB, you need to interact directly with AWS. So how did you go about that?
Yeah, they actually have a binary where it contains a local version of DynamoDB, and they have instructions on the official site in order for you to install it on your computer and work with it. Because I think they understood that not everybody, especially us down here, we don't have internet all the time, and maybe our internet speeds will not, because it's really difficult trying to get the idea out of your head, programming, and then you have to do those network calls, latency, and stuff like that. So it really slows you down. But with the local version installed on your machine, there's no slowing down. Your foot is on the gas, you're just going. I don't know if I've answered your question.
Yeah, it makes a lot of sense. Yeah. I mean, instead of each time you want to query the table or make changes, those network calls to AWS and back, you can develop locally and just synchronize when you're done. So yeah, that's a very powerful feature right there. So let me go to the first question from Mandela.
Yes, I need many questions.
So you want to know, can you convert SQLDB to NoSQL?
No, it's extremely not advised. Okay, listen. NoSQL supports doesn't support duplication of data. Like that's why they emphasize a lot on normalization. But the data duplication is actually a thing in NoSQL. You understand? So in SQL, there's no duplication, but in NoSQL there's duplication, so it's not actually advised. And then now DynamoDB is moving towards a feature called single table design, where all your, let me take for example, you're developing an e-commerce application, so you have the users, the products, you have the shipping, you have what else, payment and stuff like that. Each of those are entities. In NoSQL, in a SQL, each of those entities are actually different tables, which at the end of the day now, you would have to join that data. And as your table or as your application is growing, those joins become really complex and expensive to do. But with NoSQL, you have the single table design where you have one table for all of those entities. So there's no join in it. You don't have to perform those complex queries and stuff like that. So actually getting the table from SQL to NoSQL is actually, in fact, your ideology should actually change completely when you move to NoSQL. And that's where a lot of people trying to get into SQL, that's the problem that they face, because they're trying to take the same idea, the same way of doing stuff in SQL to do it in NoSQL. No, we're putting aside the old and embracing the new. So it's not possible.
Yeah, all right. I think I personally come across that question before, and there are tools that can help you migrate from your SQL database to NoSQL, but you have to remember that you're going from a strict schema to a schemaless, kind of paradigm. So it's more of a translation than like an apple for apple, comparison or something of that sort. Yeah. Okay. I hope that answers the question. I just want to remind everyone that I just pasted the link to the online survey. So just click on it, please, and it just takes a couple of seconds for you to fill it. And at the end, of course, you can leave any comments and just let us know how we can make our next meetup, very interactive and interesting for you. If there's any other information that you want us to probably get back to you later, we just let us know in the survey form. Thank you. Okay, the second question, still from Mandela. Is there any limit to the data upload size at a time? For example, can I upload a single file of about 10 GB? Yeah, go ahead, Rosius. Yeah, you can go ahead.
I think 10 GB is not even that big, but I want to talk about migration. Like I've seen companies migrate tons of data from their data centers, from their databases to Amazon DynamoDB, but I don't know about uploading 10 GB at a time. I know migration is a continuous process, but at a time, I don't know.
Yeah, actually, I
that.
think a single item, I think there is a limit.
For a single item is 400 kilobytes.
Yes, it's 400 KB. I remember it's a prominent question that comes up when you're doing certification exam. So for a single item, it's 400 kilobytes. But if you have, I think DynamoDB and S3, right? There are a lot of scenarios where if you have items that are large, instead of storing them in DynamoDB, what you do is that you store the reference to the item on S3.
S3, yes.
Right. So that's the workaround that most people use in applications, because there is a limit on the size of an item, which is 400 kilobytes.
Yeah.
Yeah. So any other questions? Not advised. Yes, not advised to do that. All right. Rosius,
DynamoDB. Yeah. Okay.
Do you have any book recommendations for DynamoDB?
Yeah, and of course. Like, there's this man called, there's this engineer, one of the best DynamoDB engineers I know, Alex Debris. So he created this book called DynamoDB, the DynamoDB book. See, it has everything from beginners to advanced. Like, it's a no-nonsense guide on getting good with DynamoDB. I actually grabbed myself a copy. And the thing is that when you grab a copy, it actually comes with a link to a social forum where you actually chat, you post your questions, you chat one-on-one with him, or if you post your question, other engineers within that forum, they actually come to your aid immediately. So it's if you want to get into DynamoDB, and if you want to take it to the sky, I think this book is the gateway. And I can sit here talking about DynamoDB the whole day, but if you don't actually get in and experience it for yourself, you'll not really understand what I mean. If you've built applications before where you had to manage caching, where you had to do stuff manually on your own, you would actually know you actually know that DynamoDB is a painkiller. You know, you feel the pressure being taken off your shoulders once you get into DynamoDB. So I urge everybody to try it out, you know, get into DynamoDB. And if you need a guide on how to work efficiently with DynamoDB, get the DynamoDB book. It actually comes also with videos. And those videos, if you don't like to read, they can watch the videos because the videos explain each chapter. It's actually him explaining every chapter. And then he ends up with about 5 real life examples. And one of the best that I've seen in there, all of them are good, but there's one of the best is him implementing GitHub. No, him breaking down actually implementing a GitHub model using DynamoDB. If you can imagine what that means, you know. So please check it out. The DynamoDB book.
Okay, thanks. So DynamoDB book, I'll try to look for a link. It should be on Amazon, right? Of course.
No, it's not on Amazon. It's actually on his, just if you just Google it, you know, you'll just get a link to it.
Right, let me look for it. The DB book.
Sure, so.
The DynamoDB book. Okay, I'll send the link. All right, I will share it after.
Yes. No, and if the cost of the book is too high, I mean, he's a nice guy. You can write to him. Like I actually wrote to him and I told him I couldn't meet up with the price of the book, so he actually sent me a discount, which was around what I wanted to spend on the book. So he was a really nice person. You write to him on Twitter, or LinkedIn, but Twitter, he responds immediately and he helps you.
Okay.
So.
And for those who are new, I'm also going to paste, you know, the link to our WhatsApp forum, the link to our Twitter, to the user group, our Twitter account, and also the YouTube channel, because as mentioned earlier, we are going to share the recording of today's session on our YouTube channel. So those are the links. I'll also share them on our WhatsApp user group. And we are exclusively on WhatsApp for now, but we're thinking by the end of this year or next year, we're going to move to Slack or to Discord so that we can, you know, branch out into other areas on AWS, like maybe machine learning, certifications, serverless, containers and Kubernetes, that kind of thing. So yeah, I think, anyway, one last thing, Rosius. We are actually doing this like some sort of series, right? And, you know, DynamoDB is a serverless database solution. There are other serverless services that are part of the serverless stack. So Rosius, can you just let everyone know what our next meetup is going to focus on?
Yeah, it's a Lambda, you know, where serverless began. It's actually at the compute layer. So we'll look at Lambda functions next.
All right, great. So our next meetup is going to focus on AWS Lambda, which is a function as a service offering from AWS, which you can use to perform computations, event-driven computations, and a lot of interesting things, right? So yeah, I think with that, we can close today's meetup. I want to thank everyone who could make the time to join us today. Special thanks to those who filled the survey form. we are going to look at your feedback and try to, take all of your suggestions into account so that we can make our next meetup interesting and interactive. So let's stay connected on our WhatsApp forum. I shared the link in the chat. And if you have any ideas, if you have any questions, if you're working on any projects, even if you want to find out how Rosius became the first serverless hero in Africa, you can just drop a message or drop a DM. And we are here to assist and build and grow the community. So even if you're an expert and you have any information that you want to share from your experience, we are actually looking for speakers and experts so that we can have many more fruitful virtual meetups like this one. All right, so I guess that's goodbye from us, and stay safe and enjoy the rest of the weekend.
Goodbye, or if you are giving us a location for breakfast.
Well, depending on how this COVID issue goes, depending on how this COVID issue goes, I think hopefully next year we're going to do physical meetups, and definitely
from next year, physical meetups will eat all that money.
Yeah, there'll be breakfast, and we are already working on sponsors so that it won't be just dry talk. We'll at least have something to eat and drink.
Yeah, sure. Okay.
All right. Goodbye, guys. Goodbye, Mr. Lucky Mandela. Goodbye, Ateh.
Goodbye, man. Thanks.
All right. Goodbye.
Peace.
Yep.